Well, by the time we have understood that this is a test for independence or dependence, this is also is applicable for categorical data. It is only for applicable for categorical data. Now, what is the categorical data? We have understood in the data type there is a categorical type, categorical data, and the continuous data, if you remember. Okay. Now, categorical data means what? When we talk about, um, let's say that when we are measuring that a type of data like animal classification like mammal, fish, reptile, or the political party BJP, Congress, NCP, Democratic, CPI, and so on and so forth. Those are the categorical data, right? Now it may be the Likert scale like good, bad, good, neutral, bad, and so on and so forth. This kind of data whenever we are getting. Continuous data is nothing but measuring the temperature, then blood pressure, blood sugar, and so on and so forth, wherein you will get the continuous scale. Okay, so these are the difference between the categorical data and the continuous data. And in case of categorical data, we use this chi-square analysis. Okay, and this is a non-parametric test. Now, why chi-square is a non-parametric test? It is a non-parametric test. Why it is non-parametric test? Because we do not make any kind of assumptions about the parameters of the population. This is a test of proportions. This is a test of proportions. Now, why it is a test of proportions? Because we are trying to take the difference between observed variable and the expected variable, and then we try to find out the value with respect to the expected variable. So this is nothing but the proportion or the ratio, right? So this is a non-parametric test. It is used for to test the dependency or the independency. It is for categorical data, and it is a method of proportion. Now, in this case, if you try to make the hypothesis, it will be, let's say, null hypothesis is nothing but P1 equals to P2 equals to P3 and equals to P4, let's say. And alternate hypothesis will be it is not equal. So P1 not equal to P2, not equal to P3, not equal to P4. We'll take a detailed example in upcoming lectures and we'll explain that. But to do so, how we can say that hypothesis is rejected or null hypothesis is accepted or not accepted? In that case, few things we need to remember. Here we are considering, let's say, 0.05 alpha value. It may be anything, 0.01, 0.1, anything. It will be given in the question, or we will understand. Let's say for any kind of management or research related problem, management, sales, um, all of those things, we consider the 95% confidence level. But in terms of medical, huge data analysis, astronauts, astrophysics, and all, we try to take, only 1% or maybe lesser than that. That means 0.01%. Sorry, 1%. That means alpha value will be 0.01. In normal cases like psychology and psychological behavior measurement, intelligence behavior measurement, all of those things, behavioral studies, generally we take either 95% or lesser than that, that is 90%. That means in that case it will be 0.1 will be the alpha value. Hope you have understood what is the significance and the value of this alpha we need to consider when we are referring the chi-square test table, right? Now, degree of freedom. Now, as I said, degree of freedom is, let's say I said that there are 4 options, 1, 2, 3, 4, something like that, and it's a linear options, 1, 2, 3, 4. In that case, we made 4 minus 1. But what will happen in terms of given structure? Let's say you are having 2 rows and 3 columns. 3 columns and there are 2 rows. Okay. In that case, degree of freedom will be r minus 1, row minus 1, and column minus 1. This is the formula of degree of freedom. Okay. And chi-square cal value, what we calculated, we know it is 0 minus e whole square divided by e. Done. Now, what does this mean? It means how based on the given data O, observed value O, I need to calculate the value of E, and then we need to use this formula to find out the chi-square cal. But what is the formula of E? How we can calculate the calculate the value of expected value? So in that case, the formula is column total multiplied by row total divided by gross total. We'll explain in detail what is column total, what is row total, what is gross total. Okay, the moment I get this value, this will be the respected of respected expected value against each and every observed value, considering this one. Okay, this one. So we can calculate based on this observed value, we can calculate the expected value out here based on the column total. That means this column total, this x, row total, let's say this y. So x multiplied by y divided by total, gross total. Okay, this one and this one, whatever, it will be the gross total. So we can find out the expected value against each and every cell given out here. We'll take a detailed example, but for the timing, if you have understood this concept, how to calculate the chi-square critical or chi-square cal value, then we have if chi-square cal is less than chi-square critical, then what we will do? We do not accept the null hypothesis. That means, we will accept the null hypothesis. That means we fail to reject null hypothesis. Clear? That means we will accept that. That means P1 equal to P2 equal to P3 and P4. If this is not, that means chi-square cal value is more than chi-square critical value. In that case, we reject null hypothesis. It means what? That means in that case, I will consider this is not applicable. The applicability is this one, P1 not equals to P2, not equals to P3, not equals to P4. No proportions are same. Hope you have understood how we can calculate the cal value, how we can calculate the critical value in detail. Okay, we will take further example to understand in depth.